In this short video we're going to look at converting between entire radicals and mixed radicals and vice versa. Firstly, let's consider what a radical is. A radical is a number enclosed in a root. It could be a square root or a cube root or any level of root. An entire radical is one where the root encloses the whole number, whereas a mixed radical is one where there is a number inside the root multiplied by a number in front of the root. Okay, so one of the key things that we're asked to do is to convert from mixed radicals to entire radicals and vice versa. So let's start off with mixed to entire. Firstly, let's have a look at the statement at the top here. The square root of 4 times 25 turns out to be the square root of 100, which is 10. And also the square root of 4 times by the square root of 25 is also equal to 10. This isn't a coincidence, and in general we can take roots then multiply, or we can multiply then take roots later. So if we wanted to convert 4 root 5, then note that 4 is just the square root of 16. So 4 root 5 is the same as the square root of 16 times the square root of 5, which from above is the same as the square root of 16 times 5, which is the square root of 80. And here we have a final entire radical. So let's try it again, this time with 3 root 7. Well, 3 can be written as the square root of 9. So we've got the square root of 9 times the square root of 7, and from above that's the same as the square root of 9 times 7, which is the square root of 63, which is of course very slightly less than the square root of 64, which is 8. And root 63 is the entire radical. This method also applies to other roots, such as cube roots. Consider 2 times the cube root of 4. Well, the same rules apply from above, but the cube roots can't be combined with square roots. They have to be the same level of root. So 2 could be written as the cube root of 8. So we've got the cube root of 8 times by the cube root of 4, and from before this is the same as the cube root of 8 times 4, which is of course the cube root of 32. And in the same way, 5 times the cube root of 2, well, we can think of 5 as the cube root of 125. So the cube root of 125 times by the cube root of 2 is going to be the same as the cube root of 125 times by 2, which is going to be the cube root of 250. Okay, converting from entire to mixed radicals is actually a little bit harder, but the method is still broadly the same. So let's have a look at this example. The square root of 72. Well, it turns out that 72 is 36 times 2. It's a lot of other things. It's 24 times 3 and various other things. But the special thing about being 36 times 2 is that the square root of 36, we know, is just equal to 6. So we're left with 6 root 2. So the process really is to try to find the largest square number which is a proper factor of the number. So all the time we need to think about the square numbers, which are 1, 4, 9, 16, 25, 36, and so on. And thinking about those numbers, what is the biggest square factor of 75? What is the biggest number in the squares list which is a factor of 75? Well, it doesn't take a lot of thought to realize that 75 can be written as 25 times 3, and then we have square root of 25 times the square root of 3, which gives us a final answer of 5 times the square root of 3. And again, two more, one's square root, one's cube root, same basic method. Thinking of the square root of 98, 98 is 49 times 2. Ooh, and 49 is in the list of square numbers. So 49 times 2 square rooted can be written as the square root of 49 times by the square root of 2, and of course the square root of 49 is just 7 root 2. For cube roots, Again, we still need to find factors, but those factors need to be in the list of cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and so on. And we've got to think of these numbers in the list. So can we factor 320 as a perfect cube times by something else? And of course, it doesn't require a lot of thought and thinking before you realize that 320 can be written as 64, which is in the list, times 5. So again, breaking this down, this is the same as the cubed root of 64 times by the cubed root of 5, and the cubed root of 64 is of course 4, so the final answer is 4 times the cubed root of 5. Well, I hope you think that those examples were clear enough, and I hope that they help you, but of course the best thing you can do is continue to practice. So please pause the video and try these two yourself. Okay, well, how did you get on? The first thing we need to do, looking at exercise 1, is to try to find the biggest square number, which is a factor of 405. It's a pretty strange number, but a little bit of thought might get you to the answer. 405 is actually 81 times 5. So the square root of that is the same as the square root of 81 times by the square root of 5, and the square root of 81 is of course 9. So the answer was 9 root 5. How about the second one? 108 is also a strange number. 108 is obviously 108 times 1, but it's also 54 times 2, and it's also 27 times 4, and 27 is a cube number. It's a perfect cube. So we can write the cube root of 108 as the cube root of 27 times 4, which is then the cube root of 27 times by the cube root of 4, and the cube root of 27 is of course 3. So the final answer is 3 times the cube root of 4. I hope you found these videos and examples interesting, and good luck with the rest of your practice.